Today we'll be talking about Day 26's material. This covers bootstrapping, which is a technique used to create confidence intervals. To start, we'll be talking about how to compute percentiles of lists, which is a key technique, key method used in computing these confidence intervals. Let's talk about how to compute percentiles in Python. The pth percentile is a value in a set that is at least as large as p% of the elements in the set. In order to compute the pth percentile, you can first find the number of elements in the set, calculate the pth percentile of that number of elements. So for instance, if you wanted to compute the 80th percentile of a 5-element set, 80% of 5 is 4. So you'd look at the 4th largest element in the set. If when you compute the percentile of the number of elements in the set, you get a number that's not an integer, you round up to the next largest integer and then take that element in the set. The function that implements percentile in Python is a percentile function. It takes two inputs, p and values. P is the number between 0 and 100 that you want to compute the percentile for, and values is the list or the array that you want to compute the percentile of. Let's move on to some discussion questions. I'll pause after each question. You can pause the video at that point and think through the answer, and then I'll answer the question. Let S be the list 1, 7, 3, 5, 9. That list isn't in increasing order, so we could use NP sort S to give the sorted list 1, 3, 5, 7, 9. Is the 10th percentile of S equal to 0? 0 is not an element of the list, so it can't be the 10th percentile. In order to compute the 10th percentile of this list, we'd see that S has 5 elements, so 10% of 5 is 0.5. We'd round that up to 1, and then we would take the first element of the ordered list. The 10th percentile of S is thus 1. Is the 39th percentile of S equal to the 40th percentile of S? To get the 39th percentile of S, we'd calculate 39% of the length of the list. That's just a little bit less than 2. We'd round up to 2 and take the second element of the ordered list, which gives us 3. The 40th percentile of S is exactly 2, so we take the second element of the ordered list, which is also 3. So the 39th percentile and the 40th percentile of S are the same. Is the 40th percentile equal to the 41st percentile of S? The 40th percentile of S is the second element of the ordered list. The 41st percentile of S can be computed by taking the 41st percentile of 5, which is 41% of 5 is just a little bit over 2. We'd round that up to 3, and we take the third element of the list, ordered list, and that's 5. So the 40th percentile is not equal to the 41st percentile in this case. What's the 50th percentile of S? 50% of 5 is 2.5. We round that up to 3. The third element of the ordered list is 5. And so the 50th percentile of S is exactly 5. Let's shift over to a Python demonstration where we compute percentiles using the percentile function. Here we have the IPython notebook for day 26, demos for bootstrapping and confidence intervals. Let's just run the first cell. That's just importing the matplotlib, it's importing NumPy and data science packages. Okay, that's all set. In order to display the percentile function, let's compute the 55th percentile of the array X listed below. This array has 6 elements. They're not sorted in increasing order, but we could use the npsort command to sort them if we'd like. Here I've saved that sorted list as Y. There's 6 items in the array, and if we want the 55th percentile, we have to compute 55% of 6. You get that by multiplying 0.55 times 6, and here we see that 0.55 times 6 is a bit bigger than 3. We round that up to 4, and that means that the 55th percentile is the 4th element in the ordered list. That's the number 34. We can also get this by using the percentile command. Percentile 55, x gives us the 55th percentile of the array X, which is also 34, as predicted. Now, we get down to the next heading, which is sampling and estimation, and this is our cue to shift back to the PowerPoint presentation and carry on from there.